Okay, so Julien da Silva is our next speaker, and he's associated with Kareem's activities and in Montreal at John Abbott. And really interesting talk, story of spectroscopy, how stellar compositions made clear through deceptively simple tools. All right.
Indeed. All right. All right, thank you so much, everybody. So as previously mentioned, if you're in this room, it's because you're here for a story of spectroscopy, stellar composition made clear through deceptively simple tools. That being said, before I get started, I just want to give you a bit of an outline of where I'm going with this talk. First, I'm going to tell you a little bit about who I am and how I got here standing in front of you in Toronto on this stage. I'm going to talk to you a little bit about the theory of stellar spectroscopy, give you a little bit of introduction so we're on the same page. Then I want to let you know how you, as an amateur astronomer, can get started. Then I want to talk about what I'm a great deal focused on, is how spectroscopy is good as science outreach, something that Kareem is also focused on as well. And the last little bit will be dedicated to questions if we need it. So, who am I? My name is Julien da Silva. I've been a member of the Royal Astronomical Society of Canada in Montreal since 2018 in the winter. I actually, incidentally enough, took Kareem's class in the winter of 2018. And I'm a John Abbott College alumnus. I'm currently studying at McGill University in bioresource engineering, which is effectively in environmental engineering. But I'm looking forward to starting a computer science degree in the next fall. That being said, who I am has a great deal to do with the speaker Jenna 2 speakers ago and Kareem, as I'm not only a youth member of the RASC, a minority among RASC individuals, but I'm also one of Kareem's students. And that segues me very well into what I'm about to do, and that is to thank a number of people. Right, sitting in the audience tonight is my mother, my father, my girlfriend, my aunt, and my brother, who came all the way from Montreal to see me give this talk. So I'm really excited to give this talk to you guys. And as well, I have to thank Kareem, because Kareem's the one who got me into this in the first place. He's the reason why I'm standing up here today telling you about something I'm really, really passionate about. So without further ado, let's jump into it, shall we? Let's talk about stellar spectroscopy for a minute, just so we're all on the same page. So spectroscopy, defined by the Encyclopedia Britannica, is the study and absorption and emission of light and other radiation by matter. And as you'd expect, if it's stellar spectroscopy, we're applying that to stars. In effect, this is the study of starlight. And if that doesn't get you excited, I don't really know what will. Now, scratching the surface a little bit here, let's talk about stellar classification. According to the Morgan-Keenan system, stars are classified from O to M, denoting heat, with O being the hottest, M being the coldest. You can remember this by this cute mnemonic, O be a fine guy, kiss me. And then these stellar classes are subdivided into 9 numbers, with O being the hottest. Now, it's also designated with a Roman numeral indicating size. And immediately, when I say this, people always wonder, well, what is our wonderful sun classified as? And our mighty sun is classified as G25. Impressively unimpressive, actually. One of the smaller stars. And we can see that on the Hertzsprung-Russell diagram. Now, this diagram plots every star that we have discovered on a very nice, handy-to-read graph. Now, the big boys, Orion's left foot, like Rigel, is in the top corner. Is on the top there. Our sun is directly in the middle, and stars that are red dwarfs, like Barnard's star, are near the bottom. Thank you. Now, with that out of the way, we can really dive into what the crux of stellar spectroscopy really is about, and that is the concept of emission of light. Now, for every element, and indeed molecule, there are a handful of these wavelengths in the visible spectrum, right, that are absorbed and emitted, as you can see here. Knowing this, right, if I were to use a special spectral filter and break up the white starlight, into colors, much like a prism on a Pink Floyd album, I noticed that certain wavelengths are missing. And that's very visually clear here. Now what that means, right, is that hydrogen in the star absorbed the wavelengths. So in this way, it could be said that hydrogen has left its unique chemical fingerprint on the element, right? And indeed, every element has its own unique fingerprint. Sodium, mercury, lithium, etc. Now this is rather fascinating, because this is a spectrum of a star, right, gathered using spectrum analyzing software. And what we can see very clearly in this graph is our dips in the starlight. This curve isn't flat. Those dips are the absorbed wavelengths of light, and that is the chemical fingerprint of the elements. By using spectroscopy, we can isolate and identify elements in the star, effectively revealing the composition of a star based on its starlight. We can also tell a thing or two about its density. Thicker dips mean the star is more dense. Now you might think this is really cool. You as an amateur astronomer might say, wow, this is fascinating, but how do you get started? Well, if you have a working telescope and a camera, you're already most of the way there, and I know that many of you already do. The key to unlocking spectroscopy, then, is the spectral filter, which fits directly onto the nosepiece of you guys' telescopes. The Montreal RASC actually ended up buying one of these filters for about 260 Canadian, and we've made great use of it, as you heard in Kareem's talk. Now, they also sell an adapter if you want to attach it to a DSLR camera, which you could very well do. Now, as you may already know, astronomy is no easy feat. And spectroscopy, honestly, is no different. Spectroscopy comes with its own unique set of hurdles to deal with. Weather always plays a part in astronomy, no doubt. And due to the fact that the Earth rotates, the thing in your scope will not be there for long. And so you don't have a good amount of time to take a picture. High quality spectra can be a challenge without the proper cameras. And while light pollution always plays a part in astronomy and what you can see during that night, lights can be devastating to the accuracy of your spectra. Even the sunlight reflecting off the moon ends up coming through in your spectrum. So you have to be very, very precise with what you get. But let's say you do this. All right? Let's say you do end up taking a really nice picture and the stars align. What can you expect? Well, I had 3 group members during a project in the winter of astronomy. Danielle, Virginia, and Abu Bakar, who could not be here tonight. But they took some excellent photos, and you can expect something like this. So there's the star Sirius and the star Pollux with their spectrum clearly visible through our spectral filter. And so that is what we will be analyzing in the software. Here are a few other photos. There's Rigel, the left foot of Orion, Vega, another bright star in our sky, and Alberio, a binary star. Now let's get to the analytical side of this, because as amateur astronomers, you have these tools available to you. Now I should disclose that I'm not being sponsored in any way when I say this. The software that I would use to do such an analysis is RSpec. So RSpec is a free, it's a licensed software, but you can get a 30-day free trial. If I'm not mistaken, the Montreal Centre has a license on this. And you can import photos directly in and get started right away, right? So what I want to do at this point in the presentation is talk to you a little bit about what I ended up doing to get some of these spectacular spectra. And so this is the interface of the software, and here is where you import the photo, right? And so you can orient the photo in the software, and this is what you'll get. So it actually analyzes properly the pixels of the image and gives it and orders it, from left to right, and you'll end up with a light value, an intensity versus pixel, right? And so there's your spectrum in the software that you'd be using if you took a spectral photo, right? So once you've done the calibration of the axes, right, the axes are now calibrated in wavelength. And this is important because in spectral analysis, we're going to be looking at wavelengths of light. And so you can see the spectrum goes from blue to red, and there is the spectrum of Vega. This is an image of Vega. And there we go. Now, as I mentioned earlier, we are looking for the chemical fingerprints of the elements, whether it be hydrogen, helium, or so on. Now, as amateur astronomers, we should all already know that stars burn hydrogen. So taking a look at this button right here is the elements library. Let's take a look at what we can do with that. Well, once we click hydrogen from the element library, and I know it's a little tough to see here, but there are many choices to choose from, including helium, we can take a look at where the wavelengths of light come, where the chemical fingerprint of hydrogen actually is. And so if we take a look at that, maybe in depth, you can see clearly that in the spectrum of light, there are dips in the spectrum. That is to say that the wavelengths are missing. Proof that hydrogen is present within the star. And so a final product might look something like this. This is Danielle's work, and she proved very clearly that hydrogen is present within the star at the aforementioned wavelengths on the slide. Now, better yet, we can even compare our amateur spectrum to some professionally taken spectra. Now, this is called the reference library. This is a library of professionally taken spectra of different categories of stars. Now, Vega is an A05 type star. And if we compare our spectrum to the professionally done spectrum, which, by the way, is across a larger amount of wavelengths because our cameras are not sensitive to those wavelengths, we can see that it kind of matches up, but it's a little strange. But there it is. The dips do match, very much so. And with the inbuilt feature to correct for the instrument, for the camera, we can actually find that, and I won't bog you down with the details here, that you can get a curve that actually matches the shape of this professionally done spectrum with only the amateur astronomy tools that you have. Now, we did this. We took those pictures, by the way, with a 6-inch Dobsonian with a 900 millimeter focal length and an eyepiece of about 10 to 25 millimeters, which gives you about a 90 times magnification to about a 36 times magnification. So we weren't working with amazing equipment here, right? We did do with what we had, but we ended up with some really, really nice results, right? And that's realistically not just the tip of the iceberg, right? We're looking at the spectrum of stars, but there's so much more that you can do with this, right? And that's kind of what I want to get across here, is that you're kind of rewarded for exploring the software for yourself. Now, as amateur astronomers, I know you guys are more than used to tinkering around with, the tools that you have. And so it's really, really excellent that built into this software are instructional videos, right? Instructional videos built into the software, which can help you go further than what I have shown you today, right? And that's really great because it's not just the spectrum of stars. Indeed, as I said before, it's not just elements, but molecules themselves who are also capable of seeing who also have a chemical fingerprint, sorry. And that's good because if you point your telescope at, say, Neptune, you'll be able to detect its methane atmosphere. These tools are powerful despite being something that you're all accessible to. And that's kind of what the mission of RSpec is all about. But this is my main point of interest, and it's spectroscopy as a science outreach. Now, the best part of amateur astronomy, in my opinion, at least in my experience, aren't the stars or the telescopes. And in my experience, as a member of RASC, joining it for the first time and meeting all the amazing RASC members there, teaching me about astronomy, showing me a telescope for the first time, I was impressed more with the people, right? The people that I shared that astronomy with. And it's one of the reasons why I'm so proud to stand here in front of you today. Because I love sharing astronomy with people, and I love sharing science with people. So if that's the case, if that is true, what makes spectroscopy worth sharing? Right? What makes this topic so special to me that I want to come up here and share it with you? Well, as someone very much who cares a great deal about science education and science literacy, I believe that spectroscopy is almost the next logical step forward. Right? It occupies this unique space between complexity and accessibility in a way that not many other things do. Spectroscopy is almost like a bridge to a more complex side of astronomy. And in the limited time that I have with you today, I was able to get across what are effectively the fundamentals of getting not only yourself started, but the basics of the theory itself. And I think that's a magical thing. When we're out there with our telescopes at these public events, what I forgot to mention was that, well, I will mention it, but it's that RSpec works in real time, right? And that is to say that you could have a laptop sitting next to you with your telescope and have a live readout of exactly what your telescope is seeing if you had an astronomy camera or an astronomy video camera. And that's powerful as a tool, right? It's also incredibly visual, and I think that's another very important thing, is that we're not bogging people down with math. We're not bogging people down with theory. We're showing them visually pleasing and easily read graphs where you can identify very clearly the chemical fingerprints of hydrogen, where you can very clearly identify the chemical fingerprint of even methane, right? These are things that are very important when it comes to approaching people with science, when it comes to approaching people with something that they haven't seen before. How many times have you asked someone, oh, do you want to, or what do you think of science? And they tell you, oh, I'm not a science person. Right? I don't want to hear that anymore. I don't want to hear that people aren't science people. And that's kind of why I value astronomy so much, is that it's a gateway into science in a very unique way. And like I said before, I told you I was going to mention it, is that it operates in real time, right? So you could realistically have your laptop set up next to you and show people the spectrum in real time. See the star change in real time. Right? That's incredibly valuable. Suddenly the stars aren't static anymore, right? The point in space is alive, and it's really quite fascinating that that is the case. It's also relatively inexpensive, right? Like I said before, the RASC got collectively in Montreal a spectral filter, right, that goes on the nose piece of your telescope, and we've only scratched the surface, right? The value you get for your money with one of these filters is incredible, right? And it opens up a whole new area of astronomy that breathes life into what you're doing all of a sudden. But one of the best reasons of all is that getting excited about spectroscopy means that you get excited about broader science. Right, spectroscopy doesn't just have uses in astronomy, and while I use it for astronomy and I get a kick out of that, that's not all it's used for. Spectroscopy is used in virtually every field of science, whether it be biology to detect the presence of chemicals in liquid, to chemistry for the same reasons. We also use spectroscopy to discover the Big Bang, redshift and blue shift, right? And it's also used in magnetic resonance imaging, something of a field in the field of medicine, right? Biology, chemistry, physics, medicine. Spectroscopy is a gateway to that. It's in a way, it really does stop people from saying, I'm not a science person. Spectroscopy really has something for everybody in this way, whether it be by wearing some spectral glasses, right? Some just for a light show for children to point at a white light and have it spread into its constituent colors, or someone in the field of science, right? By cataloging every single chemical fingerprint that there is to exist. Spectroscopy has something for everyone, and I think that's really kind of what makes it so wonderful and so magical. And yeah, effectively, depending on how far you want to take it, like I said, whether it be by wearing glasses or by truly diving deep into this kind of software, you get out what you put in. Right? And I think that's a really big takeaway when it comes to something like this. Now, we've come to the end of my presentation. But before I take questions, and I really do want to hear from you guys what you guys think of this, and if you are willing to incorporate it into you guys' your centers, I want to close with something very important, and it's a matter that is close to my heart. I sincerely love astronomy, and I love science. And I care a great deal about a scientifically literate population. And at the risk of getting political, we live at a time where skepticism, critical thinking, and reasoning skills are values at the heart of scientific practices. Values at the heart of scientific practices are incredibly necessary to function as a human being. And that's why I value astronomy and science outreach effort. Because in my opinion, astronomy is one of the finest ways to get people excited, truly, about science. See, RASC Montreal hosted this public event in a community called Westmount in Montreal. And that was last year, I can't remember what month, but we set up our telescopes and we allowed these people to look for themselves. We just had them up and they just came by in this community and they wanted to take a look at whatever we were looking at. And we had lineups, right? And I'm sure that's not new to you, but for me, the first year, that was the first time. And the smiles we put on those people's faces at night, people young and old, that's something I'm not going to soon forget. And if I'm being honest, one of the reasons I got into this astronomy, spectroscopy thing in the first place is that I hope that by including spectroscopy into our regular astronomy routine, I hope that spectroscopy can become part of those smiles as well. So it's been a pleasure having you as my audience today. I've been Julien da Silva. Thank you for listening.
Thank you very much, Julien.
Do we have any time for questions?
We certainly do.
All right. Yeah, if you guys have anything, please. Yes, David.
I do want to say that we made a point of trying to get as many young people involved with the GA this year, not only through papers and posters, and so I'm very glad you were able to make the trip and address us.
An absolute pleasure. Oh, so much fun. I love it here, guys.
Okay. Your microphone.
Hi, my name's Dave, and I'm from the Montreal Centre, and I'm one of the board members that helped to push for the RSpec Graticule, and I can't say how proud I am and thrilled that a couple of years later, these are the results that we did for the educational mandate that we have in outreach. Not only are we showing pretty things to the public, but now we're involving students with science and actually producing results. Just to say that if you do decide to invest in the filter, look for the 100, the one called 100. It has 100 graticules per inch versus the 200. I was told it's better for the type of equipment you're using. It's easier results. But very well done, very professional. I'm really proud.
Thanks so much, David. No, seriously. That's a really interesting point, and I was going to include it, but I didn't want to bog you guys too much with details. The company that makes RSpec, right, this free software, and like I said, I really don't want to come across like I'm a sponsor or anything, also makes these spectral filters, right? And it's a really great company run by this guy, Tom, who's become a bit of a hero among me and my friends. He's a really great guy. On his website, he has a live chat. You can talk to him about anything spectroscopy related. It's a really great company. And you should look into it for inexpensive and really great spectroscopy tools to include in your center. Believe me, it's worth the effort. It adds a whole new dimension, like literally, to what you're doing. And if you want to take your astronomy to the next level as far as science goes, right, like this is the next logical step. Seriously. Yeah.
Yeah, thanks, Julien. I think folks agree this was one of the most engaging talks this conference. So. Yeah, you're very awesome and an inspiration to us all. Yeah. So my one question, you said you put the spectrometer and the camera on a 6-inch Dob. So my question is, was that tracking, non-tracking, and have you done it with tracking, or what's your thoughts on that?
That's a really good question. And the Dob that I had, I didn't have tracking, right? So and I forgot to mention what we took the pictures with. We took the pictures with an iPhone, right? So we literally took the iPhone, put it on the lens. It didn't track. We only had a little bit of time. and we took the picture with that, right? So what the results that you saw, and believe me, we have plenty of results. We did tons of stars. We did Vega, we did Rigel, one of the 2 Albireo stars, and a few others. This was actually for a project for Kareem's class. If you're wondering what the inspiration for this talk was, besides the fact that I love this so much, was that Kareem gave us this opportunity. From his previous talk, this was our major project, right? When I worked with those people to do this, that's how we got passionate about this in the first place. And so, yeah, no, we worked with what we had. Kareem obviously gave us some of the tools to be able to do this, but yeah, no, that was. I don't know if I answered your question there with that. All right, thanks. Yeah.
Yeah, thank you very much. Yeah, I mean, you and Kareem in that program, like, you're all kind of on fire. I mean, it's amazing. And also that R.R. Lyrier spectrum, I can't believe the impact that had on me as a potential person interested in variable star observing. So thanks for that. I guess my main question, though, is what is your opinion as a young person on balancing the fun that you demonstrate with that, I believe, extremely important political message about increasing the public understanding of science? How do you balance that in your own mind and perhaps at public outreach?
That's a really good question. And if I'm being honest, part of what makes astronomy so great for public outreach, and honestly, this is like, I really do believe that astronomy is one of the best ways to get people into science right now. Seriously. It's that it is fun. I don't know if that kind of answers your question, but astronomy is entirely visual, right? So when you go up to someone and you show them calculus, right, or you show them molecules and elements and stuff like that, it's cool that it's on paper and it's cool that you can kind of see the equations, but it's very abstract and very theoretical. Astronomy is really great in the sense that I can literally stare at the rings of Saturn, right? I don't have to show you that in the textbook. I can literally show you it in the sky. And when we balance showing somebody something amazing like Saturn and stars with knowledge about these things, and then encourage them to go further with it, right? Kind of say, this is like, look at this cool thing, here's some facts about it, and then tell them that there's more out there in the world to know. I think that's where we strike a really, really good balance between showing them something amazing and then telling them about it. The next logical step, yeah, obviously for me is to tell them to do it on their own, to look at things for themselves, and just tying it back to spectroscopy is kind of showing them that next step, right? Look at this cool planet, but then here's some science. Here's some concrete science. I can prove to you that hydrogen is in this star. Look at this. Suddenly we brought in the science behind it, and it's gone from an engaging sight to something that you're engaging your brain with, right? And I think that encourages critical thinking and encourages reasoning, and that's something that I care deeply about. I think that people, like, an ignorant life is not Socrates, right? The unexamined life is not worth living, right? I believe that. Thanks so much.
Awesome.
Thank you.